Thanks to everyone for attending the panel. Welcome everyone to our panel on Gen AI and LLM interoperability in the ONNX ecosystem. So just to set up the stage here, we all know that generative AI is transforming how experiences are delivered to users. It's not just in the cloud. It's increasingly all the way from the cloud to devices in the edge. While we know and love ONNX for the role it has played in the discriminative AI role in standardization and interoperability, we are facing challenges when it comes to the Gen AI and LLM space with respect to competition from domain-specific runtimes like Llama CPP. And with this shift that's going on in the industry, we have ONNX in a very pivotal position at this point in time. So our goal for the panel today is to leave with a shared sense of where ONNX can lead, what we can improve, and few actionable ideas on what we can strengthen for this ecosystem together. And all of the users and applications that are deployed today across many devices and systems using the ONNX ecosystem. So without any further delay, we'll get into the discussion. So to start with, this is an open question for the panel. From each of your perspectives, what excites you the most about ONNX's role in the era of Gen AI? And where do you see the biggest opportunities, given the growing diversity of hardware and ASICs for AI particularly?
So I can take a crack at it. So, this hardware fungibility is actually something pretty exciting when you look at an ecosystem like ONNX. This is not like a controlled data center environment that's highly tuned. As you saw in the presentations today, there are all of these usage scenarios and configurations where you wouldn't have thought things would be running, and the ability to address that heterogeneity at the endpoint, or taking the model to where the consumer is or where the user is I think a tremendous opportunity. And it also leads to economies of scale. The more you can amortize the cost over a wider range of the populace, the more successful you're going to be.
Awesome.
Yeah, so I'm Ashish. I like to, what was said is, obviously, at AMD, we have a broad range of hardware, and a really broad range of hardware. And ONNX is one place where we can at least have a more, unified discussion with our customers is, okay, if you have a model you want to run on a variety of hardware, at least, if you can lower down to this abstraction, there's much more we can do, and we can provide you with a lot of options. Having said that, we have been with ONNX right from the day one. I personally have run ONNX on FPGA accelerators, then GPU and others. But more recently, as the discussion of this panel is with generative AI and more specifically LLMs, I'm particularly excited about the direction of OGA. But over the time of this discussion, over the period of the discussion in this panel, I think we'll highlight some of the places where we will have to add more attention. But one thing is AI, when ONNX had started, ONNX as a standard, and ONNX runtime as a standard when it was defined, and the multiplicity of the hardware which was there at that time versus where we are today, the speed and the agility at which AI moves is just every one of you know. But on the other hand, I think there is just too many of innovations happening on the hardware in terms of data type, in terms of other things. So I think it will be good to see how the ONNX community as such moves forward and keep this agility.
Thanks. I completely agree with both of you. The cross-platform nature, particularly with the hardware, but not just that, right? Even operating systems, et cetera, which Stuart would kill me for. I mean, Windows is the only thing we care about, of course. but really, that is a key piece of ONNX that continues to be the mainstay. That said, we have moved with generative AI towards large language models, or SLMs, I guess, if we go up on the smaller side. But There is still a lot of different kinds of models that people want to run, especially as you look at smaller devices or laptops and other things as well. There's still vision, you still want multimodality, et cetera. So that expressibility is something that matters as well. And I think ONNX brings all of that beautifully together. Yes, there's a lot of work ahead of us to make all this work really, really well. But that's something that we have a great starting point that we should continue to build on.
Thanks. So I think one of the things that excites me the most about Gen AI is that it's brought together the notion that we've talked about a long time, which is that most of the interesting experiences that we build with AI are more than one model. There are pipelines of many things going on together, whether it's a group of convolution nets and tokenizers plus inputs from wherever through an LLM or not. Having our ability to basically be doing inference at scale with devices that are multiplicity of hardware from multiple operating systems from X. The true power of ONNX, I think, is its ability to basically cover that entire range and also have us as a community to be able to think about what it means to be doing things at that scale. And so I think the interesting thing about Gen AI is it makes that front and center.
Yeah, my thoughts are pretty much the same. What I would add is, ONNX provides a deployment option for software vendors to target a multiplicity of hardware and device types, NPUs, CPUs, and GPUs. So it's really powerful in that it's the only standard that's trying to achieve this on the edge AI, and also it unlocks a new class of developers, right? Like for example, for NVIDIA, the GeForce, we have 100 million developers on GeForce. It unlocks a new class of applications and developers who can now start to build applications, AI applications, using ONNX.
Awesome. No, I'm really glad to see that your perspectives align with a lot of ideas that were echoed throughout the day in some of the sessions. And Stuart, you bring up an important point about inference at scale and with the multiplicity of this hardware. So specifically, touching on WinML, can you outline what the vision is for WinML with respect to the new wave of Gen AI applications? And based on your previous work, how the PC edge is different from the regular edge AI and what we should watch out for?
Yeah, I think the Windows has been an investor in ONNX since day one. And for us, I think some of the description of the panel is sort of what it's about. Is for us in Windows, whatever we do, we want to ensure that we have the ability to do something in a way which is standard in our ecosystem, which interoperates with the hardware, the software vendors. We have a very large ecosystem, and it's important for us to basically be able to handle that breadth. In doing that, what's interesting about Gen AI, as I mentioned, is that what's important for Windows is that the workload has evolved. Where we were a decade ago was that the workload was how do we make a convolution net incredibly fast and on the best possible use of the GPU, the best possible use of the hardware that we had. Today, it is an incredibly mixed workload. It is a set of models that us in the operating system are running in the background. The applications which are running in the foreground are also running AI. There is LLMs and agents that are running in the background doing many, many, many things on your behalf. Being able to handle the scheduling and interoperation of all of the hardware while the software has the ability to optimize its own workload is really the kind of the challenge that we see over the next many years for Windows, which is how to use the things that we have defined and guide their evolution so that we can ensure that what we're doing from the model and from the runtime really takes advantage of the hardware, and the operating system is able to basically handle what the user needs, provide responsiveness, battery life, et cetera, throughout that execution.
Okay. What I hear is standardization could really mean the velocity in which we could move.
Yeah, I think the interesting thing is that we're talking about a standards body. Standards body and velocity don't always go hand in hand. I think it's actually one of the true powers of what we've done sort of in the ONNX ecosystem is that we move fast enough in many regards, but we also provide the let's call it the frame by which we can move fast. We talk a lot in sort of Windows and Windows machine learning about the speed of silicon, which is that for all of our hardware partners, how do we ensure that as the hardware gets created, we can support the latest possible innovations? And I think in general, that's true also on the software side when we're looking at ONNX and models and all the latest things that people do in PyTorch and Paddle and other systems like that. I think, being able to stay agile is important, but doing that while also remaining, let's call it, the respect for the ecosystem, which is that it's not okay to just be fast on one device. It's important that we're fast and understand how we will work everywhere and make sure that, like I said, all of our customers can use the latest innovations.
Agreed. No, I think that's a great segue to the next topic. So one thing that we've seen is significant interest from ISVs and application developers on like hardware acceleration. Like they seem to value specific hardware acceleration for across multiple workloads and the client system being used for many things at the same time. And we've also seen people pointing out that to be the issue with some solutions like Olama that not have specific hardware acceleration. So the infrastructure of execution providers from hardware vendors plays a key role in providing that hardware acceleration. So maybe a question to the panel is, like what are the top challenges from the hardware vendor side they face when scaling LLM deployments with the ONNX ecosystem? Like what can we improve from the ecosystem itself, and how do they see the evolution of Gen AI on the client? So Ashish, we had a discussion recently around the scheduling issues and the multitude of workloads that run. So maybe if we can hear from the hardware vendors on.
Yeah, so there are really two ways of looking at it. From the application viewpoint, and what do LLM really stand for? At a very basic level, right? Windows as an environment, and I'll take that as an example, is a lot of people build their applications, ISVs, they run their applications. And so far it was okay, right? Your model will be 100 megabyte, 50 megabyte, maybe if you go more aggressive, half a gigabyte. But with LLMs, even with the SLMs, the size of the models are quite large. And each and every one of the ISVs would like to bring their own recipes onto the table, right? So if you just look at it from the top down, you can think of a multiplicity of applications trying to use the same hardware, and hardware companies are working quite hard to provide NPUs or better performance per watt. But at a very high level, how do multiplicity of these applications interact with the same hardware? And more specifically, when you are tied to a low-end PC, which is maybe 8 gigabyte, what do you do about it? So over here, I think there is a need for innovation, and there is a need for community to come together. And also there will be technological development in terms of what is your policy in terms of how models are brought in, how models are brought out. So I think it's a much deeper thing from the top down. But at a very bottom level, as an IHV myself, right, we basically also have to deal with the energy aspect of how you run this large language model. And some of the innovations which are happening to make it more energy efficient is going towards what they are calling it as a small floating points or block floating points. And you can see that some of these are just from the beginning, right? How the ONNX community or how you support it on the day zero is kind of going to be very important, right? And so I think on the top, how ISV or how the application developers will use constrained resources, and at the bottom level, how ONNX community can move fast enough so that some of the hardware innovations which are happening, rather than basically normalizing everyone to say that you can just run one and only one way, which is still a good way to do things, I think will be a challenge which we have to look forward to.
Makes sense.
Yeah, so as an IHV, one of the things I think about for deployment is scale. Right? I mean, if you're in an academia environment or even in a controlled data center environment where the number of variations are relatively small, a few thousand maybe, but that's still relatively small when you consider the scale of an environment like PCs where there are 100 million at least, right? If we go wide with AI compute on the PC and you're looking at a 200-300 million units a year market segment, then that scale becomes very important because essentially people have an expectation in a combination of managed and unmanaged environments that things just work. And it's easy to get things working on the first iteration out, but think about the software package you bought 2 years ago, or something that you've already deployed to your user base, and what you started with 100-person IT experiment is now deployed across 200,000 people in a corporate environment. And then you get an update downstream, or somebody comes up with a new environment, and now you have to think about, okay, does everything work as it should without regression? And those are the kind of problems I think that are good opportunities to solve on how we build a platform where people can have faith in, or the fidelity of the platform is good enough that you can scale without fear for the future. So that in my opinion is actually going to be pretty key to hardware as you get into at the edge and as a combination of managed and unmanaged environments.
Makes sense. Rajeev?
So again, from an IHV perspective, I think there's a lot of innovation in hardware and compilers and fast kernels that IHVs are working on. At the top end, there's also a variety of like LLM serving frameworks. There's open source frameworks like VLLM. There's also IHV-specific frameworks like TensorRT LLM. I think the role that for being able to deploy LLMs and GenAI models through ONNX, I think what we need is a specialized framework, and I'm really encouraged to see all the work that's happening around the GenAI SDK and the model builder. I think there's a need for greater consolidation of efforts. I see a lot of fragmentation in terms of the number of LLM frameworks that people are building, but also the number of paths to get them into ONNX. So certain things like quantization are very hardware specific. These are hard to standardize, but certain things are like the core infrastructure for running LLMs, which is what the GenAI SDK is.
Makes sense. So it's more around standardization with customization at the lower levels.
Yes. So ONNX, I think while it's moving slower, it should also think about maybe providing more flexible options for representing these diversity of model graphs and conversion pathways into IHV-specific stacks.
Awesome. Yeah, I think that's some of the work that's being done in the ONNX 2.0 and GenAI specs definitely touch on this. And yep, glad to see the synergy there. And so for all of this to work seamlessly, the health of the ONNX ecosystem is very key to realizing this vision. So maybe a question to Rajat, you've led the TensorFlow ecosystem, and ONNX runtime has traditionally delivered a lot of strong performance in the vision and discriminative AI space. So as we shift into GenAI and language models, we have new scaling and optimization challenges that was laid out by the panel and some of the talks today as well. So, and how do you see ONNX and ONNX runtime, the whole ecosystem, playing a role in the co-design, bridging across many devices, many use cases, cloud and edge, and there are multiple dimensions that are coming together here. So I'd just like to get your take on that.
Yeah. So, the strength of the ecosystem is really the people that we see here today, right? From all the different companies, the hardware vendors, the different operating systems, et cetera, that we are supporting. And we need to leverage that. That does mean standardization. That does mean spending that time to go through the things that are hard and trying to figure out the right kind of compromises that we can make to have the standards work. But what's also happening is that this whole space continues to move and evolve very, very rapidly. So how do we keep those two going together is going to be a key piece for us to deliver well. We need ways for us to continue to innovate and get ahead, and then figure out how to bring many of those things into the fold, into the standards, et cetera, as well, right? At Microsoft, we've invested a ton in ONNX, of course, from day one. ONNX runtime built completely around ONNX, et cetera. We continue to experiment. I mean, just talked about model builder and other things and sometimes more than one experiment for solving the same kind of problem. That's not, you're right. I mean, we need to make all of those interoperable. They need to be consistent over time, though, right? We still need to be able to experiment and evolve as rapidly as we can to stay ahead and support whatever is needed. Sometimes the models, and usually the models and the vendors, the ISVs, they get ahead, way ahead of the hardware, et cetera, right? I mean, the hardware cycles are just longer, and that's fine. But as it catches up, it needs to be able to understand and take on new things. But for the existing hardware itself, how do we really push the envelope? Let's say a new kind of model came in, new attention comes out. It seems to happen every 3 to 6 months, I guess. But we need to be able to support that very, very rapidly. If we wait for it to come into the standard, it's probably going to be forever, right? So how do we maintain that velocity, but not give up on the standardization, right? It's a push and pull. We're going to have pulls in lots of different directions, but then over time, we still have this group here that gets together and takes the time and figures out how do we put all that together. That's going to be key for the success. We can't give up on either of them, right? We see a lot of new things. You know, we talked about like lots of new frameworks for LLMs, et cetera. A lot of them are very point solutions, and they're great at that. It's always easier to have a point solution that just solves one problem. We should learn from those, right? And we should experiment on how we can provide more of those, but over time, how do we get more of these in the standards as well, right? So as long as we continue to do both, I think we'll be good.
Makes sense. I think you bring up an important point in the pace with which the model, the frontier models, and the ecosystem on the application side is evolving has gone up multiple fold over the last couple of years, versus the pace of the hardware cycles and the standardization bodies. So how do you think we can bridge the gap in velocity? Like, is it about there is more contribution from the user ecosystem and the hardware vendor community, or is there anything that you can share about how we can bridge the gap in velocity there?
Sure. If others have thoughts, would love to hear as well. Look, are we enabling enough experimentation on top of the core? As from the pure ONNX perspective, are we enabling others to experiment more easily, right? And one very specific example comes in Contrib Ops, et cetera, right? People are trying things in ONNX runtime. They eventually make their way, et cetera. From the ONNX runtime perspective, are we enabling others to be able to try things out more easily way before any of those are in the standard? Are we maybe enabling, like, from the hardware vendor perspective, right? There's we have tons of NPUs now. Are the NPUs limited by what we have, or are they enabled by what we have, right? Do we have the right tools, et cetera? Are we all investing as a community in those things? We talked about the IR. Are we pushing the IR and the tools around that in a good way so people can do more things with it? Really building those foundational pieces, which includes tooling, et cetera, as well, is what enables the pieces on top to really grow. And we want a lot of that.
Makes sense. Any other takes on on how are things being limited for the hardware vendor ecosystem, or how things can evolve to push the pace of evolution?
So I think Rajat made a point is, there is a generation of hardware in play at a given point of time, right? So the leverage you have based on what you have today depends on what hardware it is. And a lot of times the frameworks and others are regressive, is, you will add what is the most popular hardware will be, right? And if there are some funky features in a hardware, then how do you deal with it, right? So the Contrib Ops and some of the custom op, I think ONNX provides enough that people with a variety of hardware can export their best performance at any point of time. I think the thing is that is at a broad level, there are two things. In context of general model, what is the complexity? And because this discussion is more about Gen AI. And the good thing about Gen AI is, the model tend to be relatively clean and simple. versus, if you take a complex CNN from any time in life, right? So I think the way it is like when we compare ourselves with the velocity of llama.cpp or any other thing, I think the ONNX community has to ask this question is, how do we get the similar kind of agility on our side? And I think it will really mean that a lot of us have to work together and contribute. But one thing is there is, having worked with ONNX for some time now, I don't think it is limiting in any way. It's just that maybe a lot of people either don't know enough about it, or many times it gets obscured in, or people just end up doing something new. So that's what my viewpoint is.
Makes sense.
So I think I'd add one more thing, which is that in general, ONNX has provided a lot of, let's call it flexibility and extensions, as we talked about, crib ops, et cetera. It's really that the generative AI systems have changed the optimization problem. So when we look at what we need to do to get performance, you're talking about memory, we're talking about the way in which we have accelerators, which are now FP4 and other kind of interesting things. The problem and how we have to react to and respond to basically create system performance has changed. And so I think that from an agility perspective, the thing that really comes to ONNX is how we allow ourselves to basically reframe parts of the problem to still enable us to go quickly. It's not just about the definition of the model and its operators. It's a lot beyond that, right? And that sort of system architecture is kind of the next evolution of what we have to kind of start looking at.
Makes sense.
So I think, so a lot of times when we talk about ONNX, we fixate on the spec and the foundation, but there's an entire ecosystem of tools and compilers and hardware that I think also needs significant investment. But also it's important is, and this is something that Llama CPP has done really well, is to provide canonical examples of, running like state-of-the-art digital models, for example, on the edge. I think people learn by example, so providing more examples and providing these reference pipelines and having a consolidated effort in developing something like Gen AI and model builder would be beneficial to the community.
Makes sense. Thanks for that view. And one other item I want to touch upon is, Prashant, based on your work on security in the context of privacy, like what architecture paradigms do you see in terms of specifically tackling privacy and security with AI?
So actually, let me start with an anecdote to illustrate the problem. Periodically, everybody's aware of evaluations and self-assessment. So I get a mail from my boss saying, hey, what did you do last year or last quarter? And I said, well, let me figure it out. Let me go ask the AI. And I said, hey, can you tell me what I'm doing and what all I got done? He said, sure, no problem. So he starts building a really nice list of things that are done, very, very eloquently written. It looked really, really cool. And then it proceeded, because I guess there was some data leakage. It had also worked with my colleagues, and it started adding things that were attributable to other people, and started adding them to the things that I'd done. So, maybe I attended a meeting, but it said, oh, you got this done. Great. Makes me look really good. And then it said, hey, would you like me to add suggestions from your boss that you think your boss might appreciate on feedback that he'd given you that you'd acted upon? I said, sure, go add that in too. And it built this profile or answer, which was somewhat correct, very well stated, but had a lot of data leakage, and in some cases was factually incorrect. And then it said, would you like me to send this mail in response to the mail that you'd received? And at that point, you had the prompt, yes, no, whatever, and I was like, okay, any accidental click is going to be followed by a quick text message to my boss saying, oops. But then I said, okay, I'm going to try it. So I wrote him a mail. I said, look, ignore the next few mails that come from me because I'm running an experiment on Gen AI, and I said, go ahead and send it. At which point, the AI came back and said, I don't have permission to send mails on your behalf in the system. And I was like, okay. So there are several things that happened here, right? First is fidelity. it was going to act on your behalf. And in, today's modern world of DocuSign and everything, when somebody acts on your behalf, did you really give him that power, or is this going to be a rogue entity? The other part is leakage, right? How do you have confidence in the system that what you're trusting it with really stays with you, right? And then there is also this notion of, I mentioned fidelity, right? Is the data staying with you? Like, it pulled data from did my colleagues know that their data got pulled and merged with mine? And was that intentional or accidental, right? So there's this notion of, if you're interacting with an agent, is it really an agent, or is there somebody sitting in some country pretending to be an agent, typing with you? So when you start looking at Gen AI in the kind of agentic usages we're talking about, these things become very, very crucial. It's a fallacy to assume that it's your system, so you own everything, right? There's the people who own the system and the hardware. The code is the code or the program really owned by you, or is it licensed by you or being processed elsewhere? Is your data truly safeguarded, local on the system? Do you even know? How do you figure that out? And even if it is claimed it is, how do you know it's not being spoofed? And finally, there's the owner of the content or the models itself. But user data is actually quite a bit of premium. Now, fortunately, we're not starting from scratch. They do exist. There has been a lot of investment in establishing and attesting the quality of the hardware, establishing a root of trust, building that confidence level. So I think as we move forward, we have to look at some of these fundamentals which which actually provide a layer of confidence to the user that the claims that we are making, in terms of a Gen AI solution are actually substantiated by their experience, because the trust is going to be hard to earn. And, I know you guys might have read the story about some company, which had a very high valuation, but the AI was actually a bunch of people. So, we have to, those kind of topics are going to become increasingly relevant. And I think it's going to be very, very key from an end consumer perspective as you get into these SLMs or Gen AI, for people to be able to interact with them, that there is a measurable infrastructure where people can query and establish faith in the system, using, the root of trust protocols we have today, and also with respect to the confidentiality of the data and IP. So we've got quite a bit of work ahead of us. What I truly described did happen to me. It's the state of the art today, which shows how much progress do we have to make. Now, luckily, the state of the art was good enough in the sense that it didn't let the AI impersonate me. Though I think that could have been fixed too. But that's illustrative of the kind of problems we have to solve in terms of security. And there are a bunch of platform technologies that we can leverage that are underway to build that confidence in the system.
Makes sense. I think that definitely touches on the importance of on-device AI and the privacy that comes along with that as well. Any other thoughts or additions on the security or privacy angle?
So, as Intel, we have a deep investment in security with secure enclaves and, virtualization and root of trust, and all of these accrue. It's the good thing about the PC ecosystem is it's a consistent platform that spans all the way from, Internet of Things all the way to, data centers. And the technologies are portable to some extent. So, we only have to look at what we are doing in the cloud, for example, in terms of, providing a root of trust or attestation, and look at how some of those technologies have proliferated. For example, if you look at Windows, it makes very, very good use of virtualization capabilities, which were assumed to be cloud-centric, to provide a secure, robust environment on the edge. So you'll see more evolutions like these as we start to leverage the capabilities that exist. Attestation is another piece, which is going to be very important. in terms of the user having confidence in that, yes, the platform claimed to be something, but is that independently measurable and verifiable?
I think you're spot on. The interesting question is when we look at the platforms, what are the things that people expect for us to be securing? So a lot of times people will talk about protecting models, protect my IP, protect the weights. There's a lot of things that you're talking about, which I'm wholeheartedly on the same page of, which is I talk a lot about model integrity, which is that we build models that have a purpose, and I want to assert and ensure that the model runs exactly that way. That I know that that's the GPU that I wanted, that GPU executed the model in the way that I expected, wasn't intercepted by some rogue piece of software and the outputs changed, right? I think what's interesting is all the things that we have to do to layer all of the additional steps on top of it will be interesting, will become, again, what's the role of ONNX? How do we have a model that has all of the pieces intrinsic to it that can enforce and during development and deployment understand what it means to basically do exactly what we intend to handle in the Gen AI case, cross-prompt injection and all the other sort of parts of the pipeline and patterns that need to be evolved. So I think that, it is one of the things that's highly top of mind. As I'm Windows, you can ask me about recall. If you want to know a lot about AI security, I know way too much. But it's one of those things that, you can go through these moments that teach you and learn a lot about what it really means to basically rely upon tried and true and tested patterns for guaranteeing security. And I think in AI, especially as it's becoming part of our daily lives, it is not something that we can do lightly.
Makes a lot of sense. I think both these areas are definitely key. Security, as AI becomes more and more powerful, it'll have access to a lot more data, often a lot more personal data. And so security becomes much more important than it is today. And we often don't even think about all the data that's accessible to these models. In that sense, having ways to secure and separate things out, Edge AI is likely going to become a lot bigger piece where ONNX has a very big role to play. Talking about recall, I would love for more features like that, but they better stay on my device, right? Yeah. I don't want that going off somewhere, even if it's encrypted or whatever. There's a risk there, right? So the more I can reduce, the more I can separate those out, the more value it has. And again, the stuff that we are building applies very, very closely to these areas, right? The other one, I guess, perhaps less about this, but as we think about you talked about this AI sending an email on your behalf. As we talk about agents, and Microsoft's investing a ton in agents and the agent standards and frameworks, et cetera, these kind of things are, again, a very key part of how we think about them. We perhaps have to go beyond the idea of thinking AI is necessarily acting on our behalf, but almost like an entity itself, which has its own permissions, and really rethinking how we're doing security today, right? It's not just a piece of software that's running when we tell it to. If it can act independently, it better have the right permissions and the right model around the security model around that, which it still needs to get the right entitlements, et cetera. But its own set of challenges, more security, not necessarily ONNX and interoperability, but definitely stuff we all have to think about as we build those out.
Yeah, I think some of the things like we will see virtualization and other things in a different context over a longer time. Because when you run AI models, let us say I'm interacting with an AI model, it kind of remembers a lot of things and it is encoded in some way. Mm-hmm. And how, like, let us say I save this session and come back after 2 days, and how applications are interacting with each other. I think some of, just in the context of as more LLMs and the Gen AI kind of technology become more pervasive and they do more things rather than a program which is running, I think it will be interesting to see how the hardware vendors will look at it from securing variety of parts of this Gen AI algorithms or workloads.
Makes sense. So yeah, so today we've spoken quite a bit about ops, graphs, compilers, hardware, and all of that. But end of the day, it boils down to, okay, GenAI on my PC, what can I do with it? Like, what's the use case? So one thing I would like to end the panel with is to hear from each of you, what would be one aspirational use case looking far into the future that you would like your PC to be able to do with respect to GenAI on the client?
All right, I'll take a crack at it. So, I have a daughter who's starting to learn, computer science, and she's going through some course and did something, and she said, "Dad, I did it." And I said, "Wait a minute, you couldn't have done this. So how did you solve the problem? And did you ask an AI to solve the problem?" She said, "Of course." So, solved the problem, came back. I said, "So do you understand how the solution actually works?" She goes, "No, I just asked the AI, it solved the problem, problem solved." I said, "Okay, I need you to think about this and then come back to me, with a flow chart that explains, or a diagram that explains your understanding the problem." So I get a mail a couple of hours later, "Dad, the flow chart was too big. Here it is, here's a mail." So look into it. Obviously, you could tell it's AI generated too, right? Because it was way too complicated. It was correct, but it was like overload. So I said, okay, so that's the problem I want GenAI to solve for me, when it can, my kids are already interacting with me over mail and text messages, so I want it to be good enough so that it can raise my kids and catch them doing all this kind of things and correct that behavior. So that's my benchmark.
Makes sense.
Yeah, my needs are relatively simple. If I can get 2 extra hours, and your example, I would love if emails can be sent, projects can be tracked, and people can be yelled at, all done by GenAI, I'll be very happy. But in general, I think the potential of GenAI to learn new things, to to be able to move faster with your learning goals, or for that matter, trying new things, right? Because we talk about stable diffusion and bunch of other things. The kind of things you could do when you're not an artist, just with a prompt, are quite amazing. And I think this is already extending it to music and others. And all of us have some way of looking at things, how it should be done. And until unless you're not expert in variety of things, it just stays with you. Maybe we can be more expressive. I think our consumer may be AI. People may still not like it, but very excited about it. Yeah.
Awesome. So I would say almost 2 things. And one we already see in some ways in the cloud, which is you have this encyclopedia of pretty much unlimited knowledge or whatever, right? Growing up, I would see these Encyclopedia Britannica books. It's, for most of you, it's probably, what is that? But those, I always wanted to have those on my shelf. Now I don't need them because I can just ask ChatGPT anytime I want, except I would like to have access to it all the time in a great way, but also much more personalized, right? I mean, this idea that we are seeing with recall, et cetera, where it can remember all the things, I do want something that does that because I forget things all the time. But it has to be super secure, personal to me, that lives with me, et cetera, right? So that's sort of the one side of it. The other side is what I'm starting to do more and more, I realize, is I have some thought. I feel like, okay, this seems like a great idea, whatever. Often it's not, but how do I know? So I just go and ask ChatGPT, okay, does this make sense? How would this work? And just bouncing that idea and iterating on that with a model, et cetera, right? And this is just the very beginnings of it. I think we'll see a lot more of that. So in some sense, you have your own personal companion who over time gets to know you and that you can, have those conversations with and really connect with. These, we're seeing the early days of it, but as these evolve, we'll see a lot more. It'll just change how we do things as well. So really looking forward to more of that.
I think I agree with you on the one thing, which is that, what's interesting about Gen AI is that it solves a lot of these, what's called toil-based problems. things which take repetitive, complex steps to kind of, put together X, Y, Z. What's hard is that, if we go way back to sort of the dawn of the internet, there was Firefly and all these systems that tried to really be deeply personal with you. What's interesting is, so I like to travel a lot, and when you decide to go to somewhere to travel, like they're very personal as to like which kinds of hotels and which cities and which types of restaurants and this and that you want to go to. What's interesting is that a lot of what AI does today is it's a probabilistic system, so it takes the highest possible probability of like which thing you like, but it needs to get deeper at that understanding of, what is it, what you're like, how are you personally going to look at this thing and go in a conversation with this thing to really truly understand how to make my best possible vacation, right? The vacation is something that, is a huge part of our life. You take time out of work and family, and I wanted to make it really great. Being able to kind of really use that kind of interface to make that great, I don't think anyone's really nailed that yet. And I think the other thing is, when you go back to like what we do on a daily basis, you can use a coding system to vibe code and go really fast and build code, but we're still not good at debugging. We're still not good at having an AI look at the deep patterns of how software really work and really understand how to help people through the full development cycle. I think we're getting really good at the front end of it, but the back end of it, we're not there yet. And I'd really love to see what a AI debugger really looks like.
Makes sense.
The use case I'm personally most excited about is, learning and new ways of learning. And I think, especially as it pertains to my kid, I have a toddler, and she has a lot of questions. And, if the AI can answer a lot of the questions for her and, be her companion and kind of guide her through, the learning stages, right? That would be very useful. Also, related to that, you need to have safety and guardrails and make sure, she doesn't learn the wrong things. So there's a lot of aspects of what we talked about today, from safety to like real-time kind of responsiveness and, being a companion and having a human-like kind of feel to it, interacting with AI. All of this is important. And if I don't have to be a helicopter parent and, AI can do it for me and keep an eye on my kid, I think that's a great use case that I'm really excited about.
That's awesome. I think there are quite a few startup ideas in those discussions that we just had, but I think the underlying theme of a lot of those ideas is, comes down to, personalization, and privacy becomes a very important piece of it, from, parenting to ideas to, all sorts of things that we discuss. Privacy becomes a cornerstone to that. I think that further emphasizes and, drives my belief in on-device AI. I'm really looking forward to the role ONNX in the ONNX ecosystem, and all of us can play in driving and realizing that vision. But with that, we're over time. I'm really grateful for all of you taking your time out of your day to attend the panel and have this insightful conversation. And thanks everyone for attending. And with that, I'd like to close the panel.
Thank you.